Hello and welcome to another Java tutorial. In this tutorial, I'm going to look at the first item of the effective Java, which is about in the chapter or the first chapter, which is about creating and destroying objects. And item 1 says, consider static factory methods instead of constructors. Now, why does it support that? Why does it suggest that don't try to, sometimes it's better to use static factory methods instead of constructors? And we should realize that Java allows constructor overloading, which means, as I mentioned before, constructors are just methods, just like any other method, but they are special methods. And the main difference between the constructor and any other method in a class is that, first of all, the constructor is called whenever a new operator acts on the class, right? And the other one is that the name of the constructor as a method should be exactly the same as the name of the class, right? And however, just like other methods that we can overload based on the parameter type, we can also overload the constructors based on the parameter type, so based on the type of the parameters. And the problem is that sometimes the types are the same. You have sometimes not only based on the type of parameters but also the number of parameters. For example, you may have a method that takes 2 doubles, another definition of the constructor that takes 3 doubles. All the types are the same, but the number of parameters are different, right? So not only the types but also the number of parameters. Now, the limitation of the constructor is that you cannot overload based on the name of the parameters. What do I mean? Look at this example. Let's say I have a point class that has 2 fields x and y, right? And both are them of type double. But we know that we can construct a point from two different, this is a 2-dimensional point, and we can construct it from 2 different ways. One is from a Cartesian point of view, or a Cartesian way, which takes 2 doubles at x and y coordinates, right? And it assigns them to them. The other one is from a polar coordinates. Again, it still takes 2 doubles, but these 2 are not x and y's. These are the distance from the origin, distance from the 0, 0 point, which we call it rho, and then the angle from the horizontal axis, the angle from the x-axis, we call it phi, which is typically in radians or degrees, right? Obviously, because both angles in degree or radians are double numbers, you really cannot distinguish between them. So right now, this constructor has a couple of problems. The first one is that obviously this gives you a compiler error. So if you write this in Eclipse, it's going to give you an error because Java compiler doesn't care about the name. It only cares about the type of the parameters in the constructor and the number of parameters. If the numbers match and then the types are the same, Java doesn't allow that, right? It's a duplication. So Java tells you it's a duplicate method, point, double, double in type point. And know that for the constructor, it also says that it's a method, duplicate method. And maybe it's not, I think the reason is that they just, for this kind of error, they didn't specialize on the constructor. It's just a generic error, which applies to any method, and constructors are also methods, special methods in a class, right? So there are a couple of solutions that historically have been used, and if you really want to enforce the use of constructor for this type of constructions, if you want to make sure that the user can call the new operator and call the constructors, and it's able to create both Cartesian coordinates and polar coordinates, you have to tweak the second constructor. And there are a couple of ways. One is you can use a dummy parameter, and this is a typical approach. For example, you'd add a third argument here, which is a dummy int or short or byte or whatever. It's not going to be used, and you can clearly name it as dummy, so that the user kind of, if they read the documentation, realize that that third parameter is a dummy. However, in this particular case, a better thing is that, as I mentioned, right now this phi doesn't have a unit, so the user cannot specify whether they're trying to set the angle in radians, units, or degrees. So the better option here to add a third argument, which is an enum of type angle, or for example, which provides the units, radians, or degrees, right? So that's That's the better approach. However, this might not happen all the time. You might not need other parameters, so sometimes you're stuck with two sets of parameters that have exactly the same number of parameters and the same types. Then that becomes the problem. That's why item 1 recommends in those cases it's better to use a static factory methods. And the main limitations that these static factory methods lift from the problem of the constructor is that the name of the constructors must be the same as the name of the class. So you cannot change it here, point from Cartesian or point from polar. But the name of the method doesn't have that constraint, so it can be anything. Or you can have a factory class, another class, you can have a class called point factory that has a static factory method. So the static factory method don't need to be inside the class itself. However, this item especially emphasizes that they put the factory methods inside the class, and those type of methods usually have this kind of naming conventions of, for example, value of, etc. You can have a factory inner class, or you can have a builder class, right? So these are the typical options. So I want to head to Eclipse, just look at the first option, which is trying to enforce the use of constructor but trying to circumvent the problem of here the parameters are the same, they have the same type, so it's not a valid overload. So let's head to Eclipse, and I have already created a project Effective Java and I'm using JDK 15. So let's create a new package, let's call it item 1, and here I'm going to say create a class point, right? And in the point, what do we want to do? So we want to have a public point which takes a double x double y, right? This is one constructor, and obviously we're going to declare two fields x and y, and they're going to automatically be initialized to their default values for double. That's one of the properties of Java, which is 0, right? So you don't specify them, they already get initialized by the JVM to 0 when JVM loads them. In modern C++, if you're familiar with that, so in modern C++, they also added this kind of initialization. So the compiler initializes the values to the default. So you specify x with a uniform initialization. You don't put anything here, and the compiler looks at the type. Any type has a default initialization defined for it. So a double in C++, when you don't initialize it with everything, it gets initialized to its default value, which is 0. So this is very similar property that they added in C++. However, in C++, it's just, if you just declare it double x, it's going to be initialized with some garbage. It's not going to be, it's either not going to be initialized with anything, right? So it's going to have some garbage value, whatever value is it in the memory at the time of allocation, right? But then they decided that it's a best practice to always have some initialization of the variables. And that's one of the things that the Java designers enforced from the very beginning, that all the variables are initialized by default, right? And then we're going to assign the this.x to x and this.y to y. All right. Now what happens if we want to have the Cartesian way, basically the polar way, rho and phi? All right. X is rho times math dot cosine of phi, and y is rho math times sine of x, sine of phi, right? Now obviously this is not going to compile because it gives you the error of duplicate method. So what we can do, we can introduce a dummy, int dummy, and this compiles. And obviously in the documentation in the Java doc, which is a / double quote, then you have to specify that just not being used, right? So you just specify that this dummy doesn't matter, right? If you look at the documentation, it says that dummy not being used, not in use, or not used, right? So that's one way. If I add a main method now, you see that I can create a point. So I just use the var p1 is new point. I call the new operator, and it gives me the options for the two constructors, 1.1, 2.2, and then let's also do a override to a string method, and you accept the default, right, which just concatenates the values, the fields. And then we can now do a sysout on the P1, and obviously this works, but then we can also create now a new point, P2, which is at distance, let's say 3, x is 3 and y is 4, and I know that it's on a distance 5, and the angle is usually I believe point, it's 50 degrees something, so 50 times math dot, so it's a radian, so I'm going to convert it 50 degrees times math dot pi divided by 180 to convert it to radians, and then we can print this. So so right now the problem is that obviously this assigns this to the first constructor, so the user has to use the second one with some dummy, let's say -1 for example, and now this is calling the second constructor, and again the third parameter is not going to be used. All right, now in order to get the angle, actually I believe the math has the angle. Let's see, a tan 2, which is y is 4, x is 3, so this should give us return the angle in the radians, right? Returns the angle. So let's see, and yeah, we get 3 and 4, right? So as you can see, we can use this kind of dummy stuff, but this is not recommended in this case. The best approach here is to define a enum. We call it angle or unit, and then we say rad and then degree, right? And then here, instead of actually we can overload it with that one too. Instead of doing int dummy, we say angle unit, something like that, and then we do a switch expression, and then in Java 15 actually I'm not sure, it's I think in JDK 16, in JDK 17 switch expressions are finalized, but here we can just use the old-fashioned switch on the rod. Let's see, so we can say angle dot rod, and then okay, so we switch on the unit, and then rod, and then we're going to say that if it's rod, we're going to break, and we're not going to have any default probably, and then we're going to have a case which is degree. So this is one case. I believe we don't need these braces, and another case is going to be degree, and then we are going to have this set. So we're going to set the phi, where first we call the math a tan 2 of let's say double phi 1, for example, a tan 2 of okay, so phi 1 is just phi times math dot if it's degree, we're going to convert it to basically rod with this conversion. Let's call this phi, and then here we put phi 1 phi 1. All right, now we have a compilation error. It says that yeah, I think we probably need those braces, and then for this case, and we also need these no, I guess we didn't need these braces for the case, because the idea of the case is that yeah, so something like this, we can also indent it a little bit. So what happens here is that now we have an enum, a third argument, so this is a valid overload of the first. And then the problem here is that again the names are erased in the class file, so but then you can document this. Now then a unit is a enum, degree, or rod, for example, right? So if I go back here and try to create a second point, a third point, P3, and this time I'm going to say angle dot rod, and this should give us the same result. Yes, right? So I hope you enjoyed this lecture. So this is a traditional way of doing things. Either you try to come up with a third argument that has some meaningful property, or you just set it as a dummy, and the traditional dummy type is int. You can set it to short, byte, whatever you want. It's typically int, right? So please stay tuned, and I'll see you in the next one. Hello and welcome back. So item 1 says that consider using a static method instead of constructors, and there are several advantages and obviously a few disadvantages about this recommendation, right? So one advantage of static factoring methods is that unlike constructors, they have names. So, and the name can tell the user or the client that is using the code or the developer what the purpose of that method is. If you recall, we said that in the constructor, the name of the constructor has to be the name of the class, and that's the main limitation. But the static factoring methods don't have this kind of limitation. As I mentioned, the naming conventions for this kind of static factoring methods are from, of, value of, instance, get some type, new type, create, etc. Right? For example, our example was creating a point. So we can say from point dot from Cartesian, from polar, or of. We can say of, and the default is Cartesian, but then we can have of polar, and then we can even specify the basically the units of the angle, of polar degree, of polar rod, right? Value of, if you just pass in 2 doubles, it can default to basically the Cartesian construction. A second advantage of static factoring methods is that unlike constructors, they are not required to create a new object each time they invoke. So they are not required to create. This is another interesting thing, and this means that the object can cache. This is more about caching some other objects that have been created previously or have been created right at the moment when JVM first loaded the class in the memory. And the typical example is the integer class, the wrapper integer class in the Java JDK. And you already know that by default the numbers, I believe from minus 128 to plus 127 are cached in the integer class. So this is about caching, and sometimes we don't really need to create new objects. And this is also related to the flyweight design pattern, if you're familiar with that, because that's all about restricting the number of objects that you create and try to avoid temporary objects if you don't need them, if they have been created in the past and you just can reuse them. So it's better to save them, cache them. A third advantage of static factoring methods is that unlike constructors, they can return an object of any subtype of their return type. So this is also another interesting thing. The new operator, as I mentioned, when you apply the new operator on the class, it invokes the constructor and returns the same type. It cannot return a subtype. However, the static factoring methods can in fact return a subtype, because Java by default everything is virtual calls and everything is polymorphism is always in action, which means any subtype can be used in place of the supertype. So for example, I can have a point which is the supertype, and I can have a Cartesian point, another class, or a polar point, another class. These are subtypes of point. So a fourth advantage of static factors is that the class of the return object can vary from call to call as a function of the input parameters. And again, this is regarding the fact that really when you call a method, you can use the state. You can use the state that the object have, right? Now, I mean, these static factor methods are static, so you cannot use instance, the state of an instance object, but then you can still have static variables inside that tells you save some information and later on see what happens, right? So you can the type of the object, the return type can change based on some previous information that have been saved in your class as static members. A fifth advantage of static factors is that the class of the return object need not exist when the class containing the method is written. And again, this is dynamic class loading, right? So you just say I have a class that is there, and at the runtime it has to be on the class path. So at the compile time it also might be, might not be, doesn't matter, because you can use a the return type can be the super type, but at runtime you can construct a super type, a subtype, and then return it, and the polymorphism allows you to do that. So let's head to Eclipse and really try to look at these. So the first one, a static factor methods can have other names than the name of the class, which is the main limitation. So here let's see. So instead of having all of these, we're going to look at the static factor methods now. So static factory methods, right? So what are we going to do? The conventions are so we're going to make them public and static, and then we're going to decide on the return type. Here I'm going to return point, right? I can say of and then or from. Let's start from. We can default it to a Cartesian double x double y, right? So, and then usually when you do this, you want to make the constructor private. I mean, here we're using public, but there is really no point. So we can go private on all the constructors. Okay. And then obviously these are basically, if I comment these out, now in the main method inside this point class, these can still combine. We have still access to the constructor, so there is no problem here, just for quickly testing. But if this main class was outside, then we couldn't do this. So let's create another class. Let's call it test, and let's have a main, or we don't need to have a main method. I just cut the whole thing here. So if I cut this and put it in a test class, as you can see, it's not going to compile because we don't have access to the private constructors. So this way of constructing points is not going to work for us. And another thing that I want to mention here is that unlike C++, so unlike modern C++, which have the very powerful auto keyword, in Java we cannot use var for the return type of method. In C++, you just say auto, and compiler just figures it out. But maybe in terms of the code readability, it's better to really, I mean, Java tries to not to do that, because then the code is more readable if you explicitly mention what. Obviously Java by default allows polymorphism, so any subtype of the point can also be returned. And so this from can have a basically, so we're going to call just the whatever code we have in the so we make the constructor private, and then we just say return a new point x and y. We already have the constructor that does the job. We just we just don't let the user do it. So we can say now instead of saying this, we say point dot from. This is the concept of a static factory method, right? And then this defaults to the coordinates Cartesian, but then it's recommended to make the name as informative as possible. So instead of saying from, we can say from Cartesian. This is really the best practice, from Cartesian. All right, so from this name is completely telling the user what's going on. Anyone that reads the code immediately understands what's going on. So this is the meaning. This is the true meaning of the item 1. True meaning of item 1, right? From Cartesian. Now obviously we can have another one from polar, and then we can go ahead and add that angle unit, and then we call the constructor that takes the unit. Obviously, as you can see, we don't really need that dummy constructor anymore. So, but I'm going to keep it here. But at the end of the day, we don't really need it, right? So this is the best practice. So this is the best practice. This is the best practice in Java. We don't let the user to call the constructor because they have the same name. We cannot change the name of the constructor, but then we create a static factory methods, right? Which which is very easy to use, right? So the second one is the dummy. I'm not going to use it. The third one is instead of saying new point, so maybe let's keep it, but I'm going to say var point3 is point from polar. And again, we're going to copy and paste the arguments here. And maybe I should change the name of these. Again, the name of the variables are not saved in the class file. So when the Java-C compiles this, it's you lose the names, right? So, and obviously, if you have tried Java reflection, you know that you cannot reflect on the name of the parameters, right? You cannot check what is the name of the parameter. You can check the type of the methods, the parameters of a method, but you cannot see what their names are because the names are not saved in the class file. That just makes the class file smaller, especially if you have methods that have lots of parameters and the name of the parameters are long. Java tends to have parameters that are very long in names, and if you write everything as ASCII or UTF-16 in a class file, the size of the class files is very large, becomes large. So, and it's really not necessary, right? So the compiler Java-C doesn't write the name of the parameters. All right, so this should work, yes. And let's see what the I want to also check what the angle is here. So let's do a sysout on the angle. And I want to convert it to degrees. It's 53.13. And now I can also have basically var p4 point from polar. It's 5, and the angle I'm going to say 53.13, but the unit I'm going to say it's degree, right? And obviously the better thing to do is to move this angle outside the point. Right now we imported it, but if we don't import it, then we're going to say point.angle. Note that point is public and we're in the same package, so we have access to it. That's fine. And then sysout p4. So this should give us the same result. Yes, and I would go even further and have explicit static factory to differentiate also based on the name, because there is no limit here. And then I'm going to call the constructor or this static method. So I'm going to say rod here, and then another explicit. The more explicit you make it, it's easier for the user to use and to figure out your API. Eventually you want to make a API that's easy to figure out, right, for the end user. So from polar degree, from polar rad or radian, and then degree. So this is very explicit. Polar, the angle is degree, and yeah. So that's about item 1. There are, as I mentioned, so another fact was that we can return a subtype. But before that, there are also other things. Right now we used from in our example, which is point, which makes sense. But you can also have of polar, of Cartesian. Value of usually defaults, we can default it to one type, like Cartesian. Instance, get Cartesian point. This is also very very popular. So we can say public static point get Cartesian point, or create Cartesian point, or new Cartesian point. New Cartesian, this is also a static factory method, double x double y, and then we do the same thing that we did here. So this is another thing, because this new explicitly tells the user that this is about creating the object, new Cartesian, new polar, etc. And again, I can have a class which says Cartesian point, and we're going to say we say that this extends point, right? And then we don't have a default constructor, so we have to have a constructor here that calls the super, but for now I'm going to leave it. And then another one, polar point, right? And this is going to also extends point. And then what we're going to do here is that maybe polar point has some functionality that is different from Cartesian, so both of them have interface, and we can decide to save their information as Cartesian in both cases, right? And then let's say polar point, we can also choose to save the distance and angle, right? Which we don't really need it in Cartesian. And then when we try to create something, instead of returning point, we can return a Cartesian point, a subtype, right? So that's something that is also recommended to do based on the circumstances in your work, right? Now again, the naming from, of, value of, instance, get instance, create new instance, and again new instance or new point, etc. You don't really need to use the word instance. You can say new Cartesian point, etc. Get type, get Cartesian point or new Cartesian point, and the type, right? Just say Cartesian point, etc. So these are the basically the typical meanings of these names, and these are widely used in JDK itself. For example, from, of, value of is widely used in the wrapper classes, which is a more verbose alternative to from and of. So from, a type conversion method that takes a single parameter and returns a corresponding instance of this type. So what this means is that in our example, from takes 2 parameters, but you can also specify that, for example, public static point from a double array and then return a new point array 0, which is x, and I guess array 1. So what it's saying that from is usually for type conversion from one type. Here we're converting a double array to the type that we want, which is point. I mean, this is not really recommended because right now you're not specifying how many elements should be on this array. So someone may pass array with 1 element, which throws an exception because we have an out of bound exception. The other one is array might have more than 2 elements. In that case, only the first 2 elements are being used, the rest are ignored. So this is not best practice, and this can create confusions in this case, in our example. But what the item is saying is that from is usually type conversion. So it takes one parameter of a specific type and convert it to another type based on your use case. Of usually is aggregation. Value of is more verbose. Instance returns an instance, so this is directly telling you it's creating something. Create, get, and type. So the main limitation of providing only a static factory methods is that classes without public or protected constructors cannot be subclassed. And in our example, this wasn't a problem because we already know that a point class is immutable, and as soon as you make the constructor private, you eliminate the chance for inheritance, right? So so the point by default is cannot be inherited, right? Now if you want the users to call the constructor but not be able to extend it, then you use the final keyword, right? Here it's redundant because nobody can call the constructor, so nobody can extend it, right? Because when you extend something and inherit from the other class, in the subclass, in the constructor of the subclass, the superclass constructor must be called, but when it's private, nobody can call it. So that's why you cannot this point cannot be inherited from and cannot be extended. But in our case, that's what we want, right? A point is supposed to be immutable after the creation. But this is the limitation that the item mentions. A second shortcoming of static factory methods is that they are hard for programmers to find. Now, obviously, by default, programmers tend to just try to call the constructor. If I have a class of type point, obviously I have the tendency to write new point, whatever, pass some parameters. And after trying that and seeing that I cannot do that, then I realize that, okay, I have to construct this point object somehow in any other way than calling the constructor. Then unfortunately I have to go through the documentation, etc. So the best practice is always try to document and make it as clear as possible to the end user how to work with your API, right? So I hope you really enjoyed this item. Please stay tuned and I'll see you in the next one.